So yesterday I gave an introduction of Java. Java is a object-oriented programming language which was developed by Sun Microsystems in early 90s. So later on further they improved it, and as far as Java is concerned, we have three editions of Java. One is J2SE. It is called as Java 2 Standard Edition. Then we have J2ME. It is called as Micro Edition or Mobile Edition. This J2ME we can use with the handheld devices, portable devices, or it may be micro devices or mobile devices. With those we can use J2ME. J2ME is basically curtailed version of the J2SE. All the features of J2SE you can't find in the J2ME. So using J2SE, you develop console applications or Windows based applications. Mostly we develop console and Windows based applications with the help of J2SE. We cannot develop distributed computing based applications with the J2SE. Further we need J2EE, Java 2 Enterprise Edition, using which we can develop enterprise applications. Okay, so Java is from Sun Microsystems. Now it is overtaken by Oracle Corporation. We have three editions in the Java: J2SE, J2ME, J2EE. So Java, as far as Java is concerned, we need to discuss about two things in Java. One is JDK, other one is JRE. JDK is required to develop Java applications. Using JDK we develop Java applications, and to run Java applications we need to have JRE. JRE stands for Java Runtime Environment. This gives us runtime environment. In fact, it gives a sandbox in which all Java applications can be running. Okay, so this is going to be safe environment for the applications. Within the sandbox environment, Java applications they are going to be running. So JRE is basically Java Runtime Environment. Here it contains JVM, Java Virtual Machine, which is responsible for executing Java applications. A Java application is nothing but a Java bytecode file, I can say. So Java bytecode files can be executed by Java Runtime Environment. So JDK is required in developer's machine. JRE is required in the end user machine. So end users, to execute Java applications, they need to have Java runtime environment. They don't require any JDK, but they require runtime environment, using which Java applications can be running in the target machine. Okay, so JRE is very important. JRE is basically going to work on the target machine. So JRE we are going to deploy on top of the OS. Normally, the complete in the hierarchy, completely in the bottom we have hardware. On top of hardware we have BIOS functions. On top of BIOS functions we have OS. On top of OS we install JRE, and JRE is going to execute Java applications. To run Java applications we need to have JRE. Without JRE we cannot run Java applications. So JRE is therefore must. It's called as runtime environment. So runtime environment meaning is here Java interpreter, or we say just-in-time compilation JIT. Along with that, libraries we have. So using them we execute Java applications. JRE constitutes here a library, then followed by runtime environment. Okay, so that's nothing but there a Java interpreter, and one other thing is actually JIT, just-in-time compilation. With that, the bytecode files can be compiled into machine understandable format. So using JRE, therefore, we execute runtime applications. Fine. JRE contains two important things. One is called as just-in-time compilation. One more thing is here garbage collection. Garbage collection meaning is orphaned objects are the objects which are in the memory and which are not referenced by any reference variable are called as garbage, or they can be called as orphan objects. Automatically they can be removed by Java runtime environment. So JVM is going to be taking care of those things. JVM can remove unreferenced objects, and JVM contains actually even JIT, just-in-time compilation. With the help of that, Java bytecode files can be converted to machine understandable format, and it can be retained in the memory as long as your application is running. Okay, but to use JIT perfectly, we need to have enough memory, enough RAM is required. First time when a class's method is called, at the time that is converted to machine understandable format and kept in the memory. Subsequently, if same method is called, so it will not interpret again. It is going to be executing the compiled code already. Whatever is compiled and kept in memory, that will be called immediately. So subsequent calls can be quite fast. First time only takes some time to convert that into machine understandable format. So like this, JRE is going to be working. So as far as Java is concerned, there are two constituents of this. One is JDK, other one is JRE. JDK, in that you have a Java compiler. With the help of that, you can compile the source code into bytecode file. So bytecode file is called as here a JVM's, machine code. A particular JVM's machine code is called as bytecode file. JVM is going to be interpreting the bytecode file into machine understandable format. Okay, so JDK, with that we develop applications, and to execute applications we need to have their JRE, Java runtime environment. With that we can run the Java applications. So JDK, here Java compiler, along with that we need to have IDEs. This is integrated development environment, interactive development environment, we say. So with the help of that, we develop applications. Java applications we can develop with the help of the IDEs. We have different IDEs. One such IDE is what? Eclipse. Eclipse is one such IDE. Similarly, we have NetBeans. Even other IDEs like JBuilder is available. You can Java developer, some other version is also available. So we can use them. With that, we can develop Java applications. Okay. And what type of applications we can develop Java is virtually any application you can develop. It may be a console application, something from command prompt we execute. Similarly, it may be Windows application, a graphical user interface we have in that, like MS Word, MS Excel, such applications you can develop, or you can develop web-based applications. These days, everywhere people are using web-based applications because it has many advantages. Web has many advantages. Because of that, people are developing web-based applications. Okay, so virtually we can be developing any kind of applications. And Java has excellent support for the database connectivity. You can get connected to underlying databases. The popular RDBMS packages are like MySQL, SQL Server, or we have Oracle, Ingress, DB2. All these are popular databases. These are called as SQL databases. These days, some other kind of database are emerging. They are called as NoSQL DBs. They are based on the map reduce algorithm of the Google. Based on the map reduce algorithm, even in the big data, it is used very much. Such databases are like MongoDB, Cassandra, so Dynamo. So these are the different types of databases available. They are called as NoSQL DBs. They are not relational databases, document-based databases they are. Document-oriented databases they are going to be. Even for them, it has support. Java has support even for that. And apart from them, it has excellent support for the XML. Okay, you can have good support for the XML. Different parsers are available for XML, like say SAX or DOM parsing. DOM is nothing but document object model. So SAX is nothing but simple XML. SAX is going to be having lightweight when compared with the DOM model. So Java supports even XML manipulation. XML is actually a kind of way of presenting data. You can be presenting and sharing data using XML. XML is a plain text file. So these days everywhere people are using XML. Different industries adopted XML. For them, they have developed their own markup. Pharma has its own markup. Doctors have their own markup. Chemical industry has got its own markup. Okay, so like that similarly, many areas you have XML markup. They can use such things. XML has many advantages. Because of that, they use XML. So Java supports XML well. And apart from this, it has libraries for developing PDF applications, and you can even develop Office-based applications, something like Star Office. Star Office is equal to MS Office. It is available with from microsystem, some microsystems only Star Office also. You can create there also like spreadsheets with Impress, or you can be having some kind of writer. So with the help of writer, you can develop Word kind of applications. For them also, it has got excellent support. So, like this, Java is prevalent everywhere. Omnipresent and omnipotent, we can say. Java, you can develop virtually any kind of application with Java. It can be mobile application, it can be a desktop application, or console application, or web application. Whatever you want to develop, you can develop with Java. So, Java contains rich set of predefined libraries. They are called as packages. In Java, a package meaning is set of similar classes. We put similar classes together, we can make actually one package. Something related to, say, mail sending, you have Java mail package. Something related to graphical user development, we call it as AWT, Abstract Windowing Toolkit. So it is going to contain all Windows development related classes, interfaces. Similarly, we have to deal sometimes the collections. Objects collectively we have to deal. In such cases, we have collections framework, or we can say collections package. So like that, we put together similar classes, we can make a package. So Java supports packages. Package is nothing but here a logical container of the different types of classes and interfaces. Java is containing actually logical containers called as packages. Okay, using packages, classes can be organized. We can organize classes using packages. So Java is what exactly? It's object oriented. Everything in terms of classes only you have to implement. When you take C language, C++, you can write independent methods. But here you cannot write any independent method. Everything must be part of the Java class file only. Everything must be part of the Java class file. All the methods we must be writing within the class only, because it is object oriented. Then other thing is, Java contains different types of methods there. Instance methods and static methods. Static methods, they don't require any object creation. Whereas instance methods, they are going to depend on the objects. So what is this object? Object is nothing but you take a class and when you instantiate, you get object. For example, int is there. I mean, you can roughly compare the integer with a variable. Int is nothing but it's a specification. You can think it as a class. Int a, when you write, a is nothing but object. Like that you can think. A object is similar to a variable. Int a, with the help of int, you can be declaring there an object or a variable. So int a, when you write, you have there actually a variable called as a. So into the a, you can assign values. You can be assigning values into the a there. So a is what therefore variable. A you can think as actually like a object also. You can think like object like a variable. So using int keyword, you are declaring variable. So int keyword is called as a class. You can assume like that, and a is going to be a variable name or object. Once object is available, you can perform different operations on that. You can be passing different types of operations on that. Something like adding numbers together, subtracting one number from another number, multiplying them, dividing them, finding remainder. So all such operations you can do with the data. So here everything is object oriented in terms of classes and objects only we need to be implementing. Okay, so as I was saying yesterday, you take any programming language, it has tokens. Using tokens only you can write statements in the given programming language. So statements actually they make the program there. Program is nothing but set of statements. Either you may write sequentially or in a selectional manner, or it may be iterative. So you may write statements, one after another they get executed. That is called as sequential flow. So sometimes, depending on certain condition, you branch of control. That means when certain condition is met, you want to execute certain statements, else you execute certain statements. So like that, selectional is available for us. And sometimes what happens, you need to repeatedly execute set of statements. So that is called as iteration or iteration. Using loops, you can be doing it. So like this, we can write the statements in the Java program. But whatever statements you write, they must be part of the method. Always in a method only you have to write. So these methods can be called from other methods. A method can be calling another method. So everything you must be writing in the methods only. So therefore, Java contains here tokens. Using tokens, you can be forming statements. Okay, so the set of statements can be called as a program there. You write program, then you can be executing. And apart from these, every language should have certain types of data. When you take data, data can be in many forms. Data may be binary, data may be say like numbers, or data may be like date and time, data may be true or false, data may be something like fractional numbers, data may be like strings. In different ways, we can categorize data. Such things are called as data types. We can categorize data into different types, so they can be called as data types. Even Java supports data types. In Java, you have basically two types of data. One we call as primitive data, other one is reference data. We have two types of data. One is called as here reference data, the other one is primitive data. Okay, in Java, we have data types. So data types are going to be here. One, primitive types. So primitive types we have here. Then second one is here reference types. We have two different types of data. One is what exactly? Primitive types. Other one is reference types. Primitive types of data is going to be getting saved in the stack area. Reference types, they go to the heap area. Whenever you take any program, irrespective of language, whether it is C or C++ or say PHP or Python, whatever language you may use, when you write any program, when you execute, memory is going to be laying out like this. It will be laid out in this manner. First of all, a program has code area. Whatever code you write, it comes into that. Then second thing is here data area. So here all uninitialized variables they come. Whatever uninitialized variables are there, they come into the data area. The third one is going to be here stack area. We call it as stack area. This can be growing upwards, and one more thing is here heap area. This can be growing downwards. So we have like this different areas. Okay, so code area, data area, stack area and heap area. Stack area is used by the methods. Whatever variables you declare, whatever primitive data is available, that will be saved in the stack area. Similarly, heap area is meant for dynamically created data. Using new keyword, you can be creating the data dynamically. So such data is going to be coming in the heap area. Whatever objects you create, they come in the heap area. But whatever primitive variables, primitive data you create, it goes into the stack area. You take any program, it is going to contain four different areas: code area, data area, stack area, as well as heap area. You have like this four different areas: a code area, a data area, a stack area and heap area. These four areas are available for us. In the code area you have code, in the data area you will be having data, then in the stack area whatever primitive values you create and whatever you use in function methods, they can be coming into stack area. Similarly, take heap area. Heap area is meant for dynamically created data. Whatever you create using new keyword, that comes into heap area. Okay, our JVM can access heap area, but it can't access stack area. So it can go into heap area, it can clear the elements in the heap area. That can be done by JVM. JVM stands for Java Virtual Machine. So Java Runtime Environment JVM can access heap area and unreferenced objects can be deleted from this. That is called as garbage collection. The garbage can be collected within the heap area with the JVM. So like this, you have code area, data area, stack area, and heap area. So primitive types of data, they go into stack area, and reference types, they go into heap area. Okay, primitive types, they go into stack area, and reference types, they go into the heap area. And further, you see the difference between primitive and reference types. Just I try to refer C language in this. Suppose you write like this: int k equal to, you put some 10. What is happening in this? K is a label name. For a memory, we put label. For a memory area, we put a name. That name is called as your K. So you are moving now 10 into that location. You are moving 10 into that location. So in that location, you have a value 10. So 10 is what exactly now? 10 is a data which is available in the location K. K, these variable names also something similar to our house names. To take a colony, in the colony there may be some 1,000 houses. Okay, each and every house may be having a name. In fact, if the 1,000 houses are divided into, say, some 10 streets, in each and every street, if there are 100 homes, normally how do you refer the houses? 10 by 0, 10 by 1, 10 by 2, like that. Similarly, 0 by 0, 0 by 1, 0 by 2, like that you may be referring. So same thing here also, in the memory it happens, but every house can have certain name there. Using name, we can refer it. So names, why we use? It is our convenience. We can easily understand with names. So therefore here what we put, int k equal to 10. K is nothing but a name for the location. Automatically a name for a location, a name is given with the help of this. So using k, you are accessing that location. Okay. When you write here int k equal to 10, 10 will be saved in the location k. So here both variable and data are staying in the same location. Such data is called as primitive data. So here what is happening? Variable as well as data, they are staying in the same location. Location name is k. In that location you have data 10. So that is called as primitive data. But when you take here something like this here, int, say star s, I put like this. This equal to, I put malloc, memory allocation of 2 bytes, I write like this. So what is happening in this? We have a variable called s. This is going to contain an address of some other data, some other area address it can have here. Int star s equal to malloc of 2. With this what happens? S is going to be pointing to some other location. So location is exactly what, say some 1000. This is address. Inside this you may contain data something like 20. So in the 1000 address you have 20. 1000 is being referred by s here. So s is what here? Reference variable. It can be referring other locations. Using s, you are reaching a location. So in that location whatever data is there, that we take. So that's why it is called as here a reference variable. S is what exactly? It's a reference variable. So with the help of s, you are reaching some other location there. So all objects, they will be treated like this in the Java. Whatever object you create with the help of new keyword, they are going to be reference variables. They go into the heap area. This is the difference between the primitive and object data or reference data. So primitive data, wherever you declare variable in the same location, primitive data is available. But in the case of reference variables, the reference variable is in one location, data associated to reference variable will be in a different location. Okay, so using reference variable, you can reach that location. Like that, normally we have here heap area. There you can be maintaining the reference type of data. So data can be primitive type data or it can be reference type data. We have basically two types in this: primitive types as well as reference types. Fine. Now here, let us discuss about the primitive types. Okay, when we look into primitive types of Java, we have predefined types like a byte type of data is available. Then here we have short data is available. Then we have integer data available. Then we have long data available. Then followed by here similarly we have data like this. So float data is available for us. Then one more thing, double data is available, and other one is going to be carry data, and last one is here boolean. So like this, it is going to be different types of data for us: a byte data, short data, int, long, float, double, char, and boolean. Okay, see, Java is called as a very simple language. They did not make it too complicated. They made that really very simple. Reason, when you look at the types of data, if you compare with other languages, probably you compare with C or with C sharp, you find so much confusing sometimes in that. See, in the case of byte, sometimes they say S byte, sometimes they say byte. S byte meaning is what? Signed byte. Byte is going to be unsigned in the case of C sharp or in the case of C language. But here, byte data is going to be always signed, as well as here it is signed only. That means Java supports both negative and positive for the integers. It does not have any concept like unsigned. With Java, we don't have such mechanism. Everything is going to be signed only in the Java. We don't have anything like unsigned in this. We have everything like signed only. So byte is what? It can support both negative and positive numbers. So for this range can be here. The size is how much here? 1 byte. We require 1 byte for the byte type of data. Range for this is going to be -128 to 127. This can be the range for the byte type of data. This can accommodate data from -128 to 127. So this is called as here byte type of data. Now when it is short, in the short it's going to be here 2 bytes. This one is what exactly? 2 byte data. This is going to be 2 bytes. It can accept the range from -32,768 to, here it is 32,767. This can be the range for the short integer. A short integer requires 2 bytes of space. The range for that is what? -32,768 to 32,767. This can be the range for the short. Short meaning is what? Short integer this is. When you say byte, byte is also integral data. It can support values from -128 to 127. In the case of short integer, it is 2 bytes. The range is -32,768 to 32,767. When it is integer data, here it is 4 bytes. So this is going to be here 4 bytes. You can have 4 bytes of data in this. So for that, -2 billion, 147 million, this is 384,000, some data, some range is available for is 2, here it is 2 billion, 147 million, then 384,000, followed by xxx minus 1. This can be the range for the integer type of data. So here it is 4 bytes. That many big numbers we can hold in the integer data. Okay, that will be the range for the integer. When it is long, actually this is going to be 8 bytes. So I could not remember exactly what's the range for it. Very big range we get. So long is going to use here 8 bytes. Okay, a byte requires just 1 byte. The range for that is going to be -128 to 127. And in the case of short, it's 2 bytes. We have a range from -32,768 to 32,767. And for integer type of data, it's 4 bytes. The range is so big for that. In the case of long, it's going to be 8 bytes. That means more and more bigger it is going to be. All this is for actually supporting integer data. Okay, next thing is here float. Float also requires here 4 bytes. Even float requires here 4 bytes. But this is what exactly? Single precision. Single precision meaning is, suppose you have here, just a minute, I launch calculator. Suppose I divide here 3, sorry, here, I do 22, then divide with the 7. Result is going to be 3.1428, like this we get. So here I can put data. So here it is pi equal to 22 by 7 I have written. So here value get like this 3.142857. When we use here float type of data, the precision can be up to only 6 digits. After that, we don't have the precision. Up to that exactly you can get the number, but after that there is no guarantee of the number. But when you take double, in the case of double, this is going to be up to 15 digits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So up to 1, 4 you get the required precision. Up to that we can have precision, after that there is no guarantee of precision. So this is called as here a double precision. And float is what? Single precision. Double is going to be double precision. For float we require 4 bytes and for double we require 8 bytes. Double is going to use here 8 bytes. In this you can contain fractional data also. We find both integer data and fractional data in these floating point type of data. A byte is going to be -128 to 127. Short is actually 2 bytes. Integer is 4 bytes. Long is 8 bytes. Float is going to be 4 bytes. Double is going to be 8 bytes. All these are called as here compatible types. These can be called as here compatible types because all of they belong to numbers. But here you have certain problems. For example, you take short data, try to assign to byte. That can give error for us. Why it gives error? What is the reason? Suppose you have like this. I just delete this here. Suppose I have a number like this, byte b equal to, put like 100. Similarly, short s equal to, I write 100. Okay, or I write just 80. In the byte you have bigger data when compared with the short. But when you try to assign b equal to s, it gives error. What can be the reason here? Byte b equal to 100, short s equal to 80 I have written. So when you try to assign b equal to s, it is going to give first of all error for us. It will not allow us to assign. Though they are compatible types, here b is what? Smaller type, s is bigger type. So s is what? Bigger type, b is smaller type. S can contain more data, b can contain less data. So in such case what happens here? You may lose data if you automatically assign the value to b. If you write some code like this, when you try to assign like this, what happens? You may lose some data. Data may be getting truncated. Because in the S you can have 2 bytes of data, in the B only 1 byte of data. You just compare with the bytes only. So what will happen with that? You may lose some data whenever you try to straight away assign S to B. This is one possibility. So therefore, it does not allow. Compiler can give error in such cases. Though they are compatible types, here it does not allow you to, convert a narrow conversion. This is called as narrowing conversion by default is not supported. It does not support narrowing conversion because a short integer cannot be converted to a byte because byte requires only 1 byte where a short requires 2 bytes. If you try to assign like that, it gives error because s cannot be converted to byte. Whatever data you have in the short integer cannot be kept in the byte. Overflow takes place. That means if it's not fitting exactly in the byte, what will happen? Data you are going to lose simply. So truncation of data is there. So if you truncate data, there is no point in that. That's why it does not allow. Okay, so this is called as narrowing conversion. Conversion can be called as here narrowing conversion it is. This is going to give error for us. In such cases, you can do typecasting. Typecasting meaning is, you can put like this, b equal to, you put like this, byte, then followed by, try to put s. In such cases, data gets truncated and only truncated data is going to be available in the byte there. How it happens? See. You have here a variable short. I write here short s equal to 300. Okay. Then I write here byte b equal to, in this some 10 I am making like this. Now when you write here b equal to, put like this here short, then followed by, try to assign s, what will happen? See in this. When you look at s, it is 300, 2 bytes it is. When you convert the 300 into binary format, how it comes? See. We take here 300, convert into binary format. There is no provision, I think, to convert into binary in this. There is no provision. Edit, view, scientific only. Okay, view, then programmer calculator. Let us see like this. You have in this the binary. I enter 300. I convert into binary. What we got in this? We copy this and try to put here. Okay. Similarly, we take 10. We take here byte. A byte is going to contain how many locations for us? 8 locations. 8 bits are in the byte. This one is containing here 16 bits. So therefore, what happens? It can take here 0, 0, 1, 1, followed by 0, 1, like this. Up to this only it can be taking data. This is containing here 8 bits for us. So here B equal to what will be assigned here now? B equal to, it's going to contain this data. Now what value we can get with this? Units position, 2's position, then 4's position, 8's position, 16's position, 32's position, then 128 position, 256. 32 into 1 is how much here? 32. Then here it is 8 into 1 is 8, that is 40. Then 4 this is. Result is going to be 44 in such cases. When you assign here short s equal to 300, then byte b equal to 10. Later on, if you try to assign s to b, what value contain in the b, you are going to contain s. So what happened to rest of the 256 there? They got truncated. The data you lost. So with this narrowing conversion, always there is a possibility of losing data. You may lose data, that's why it does not allow. How it happens? See in this. You can look at the code, you can find out that. So here what I do, I just write some piece of code here. I put here short integer, short followed by s equal to some 300 I put here. Next, byte b equal to, I can assign 10. Okay, if I try to assign s equal to in this, okay, here right, now s equal to, sorry, b equal to, try to put here s. First of all, it gives error for me. What error it is? See, when you move mouse pointer over it says, cannot convert from short to byte, it says. Because short is a bigger type, byte is a smaller type, it does not allow. But here now what I do, I can forcefully convert it. By using byte, I can be converting like this. Now error disappeared for us. Let us try to print this. System dot, then out dot println. We put like this. Followed by try to print here b. What result we get? See in this. So what value we should have in this? In fact, we should have here 300, but data gets truncated for us. You have here data, how much? That should be now 44. You have to get 44. Let us try to run and see what you get in that. It says here 44. Data is going to be 44 for us. From the available 2 bytes, only last byte is getting assigned here. The first byte is not going to be getting assigned. Okay, and here in this, what is happening exactly is, it is using, in the Intel machines, we use a concept called as little endian. You might be knowing about this, little endian and big endian. There are 2 concepts. One is little endian, other one is big endian. There are 2 concepts associated with the hardware in fact. Yesterday we were discussing about, one is RISC and other one is what? CISC. I was saying about it. RISC is what? Reduced instruction set computing. CISC is complex instruction set computing. So when you look at RISC, there it is going to be using a big endian concept, whereas CISC uses little endian concept. What is little endian and big endian? You see, we have there S. So S is what exactly? It is a variable. Now it uses 2 bytes. The bytes are positioned like 1000 and other one is 1001. You assume like that. They are the byte numbers. Okay, they are the byte numbers 1000 and 1001. They are assigned like this. In the case of B, that may be some 2000. Okay, so here what happens in the case of S? Low data first of all is going to come into 1000, then it comes to 1001. So therefore, in the 1000 what data is available for us? 0010 is available in the 1000 location, and in the 1001 we have only 1 in that 0001. Like that, it's going to be available with the highest numbered byte. Lowest numbered byte is 1000, highest numbered byte is here 1001. In the case of B, it is lowest numbered byte again. So therefore, from lowest numbered byte, data is taken and it's going to be assigned to here to this B. Like this, what is happening? Data is truncated in the case of this operation here. Byte B equal to 10, B short S when you write. Here forcefully you are trying to convert, therefore here data may be getting truncated. That is happening in the case of this assignment here. B equal to short of S we have written. So with this what happens? Data gets truncated here. Data is going to be getting truncated. Because of that, it was not allowing us to here automatically assign that. When you put a typecasting mechanism, data can be getting assigned now, but you lose data in that. So this concept is called as narrowing conversion. We can say this as narrowing conversion, but widening conversion is supported without any problem. So what is widening conversion? See this. Here one more type of data I put here. Byte, then some k equal to put 100. Okay, now try to assign s equal to 100, s equal to k. There is no problem with this because k is smaller type, s is higher type. So 1 byte of data you can accommodate in the 2 bytes. Therefore, there is no problem. It's going to be printing k. So this concept is called as here widening conversion. A smaller type can be converted to higher type, but a higher type cannot be converted to lower type automatically. If it is allowing such conversion, you may be losing data. Data may be getting truncated as it happened with the short s equal to 300 byte B. So here we are losing data. With narrowing conversion, you lose data. With widening conversion, you don't lose any data. Now try to print it. System dot out dot println followed by put here k. With this, what is happening now? K is getting printed. K will have now a value of 100. Okay, so, sorry, not k. This is s. S will have a value of now how much? It can have here 100. So whatever value you have in the k, that can be assigned to S here. Run this. So it can be printing for us 100. 44 and 100 we are getting like this. So here therefore Java does not support narrowing conversion automatically. There you must use type conversion, but it supports widening conversion. A lower byte can be converted to higher byte without any difficulty, but a higher byte cannot be converted to lower byte. So a higher type cannot be converted to lower type. Reason, you may lose data, but a lower type can be converted to higher type without any difficulty. So this is converting from lower type to higher type is called as widening conversion, and from higher type to lower type when you try to convert, it's called as narrowing conversion. So narrowing conversion is not supported in the Java language. Okay. So when you come into this here, further we were discussing about the here float double. These are called as actually compatible types. As I was saying, these can be compatible types. Now next thing is what here? Character type of data also we have here. Character type of data. This is compatible with the byte in fact. We have a character type of data. Character means here we need 2 bytes. In the C language, you have a character type of data. It requires only 1 byte. Because with C language, we deal only with the ASCII characters. What is exactly ASCII? ASCII stands for American Standard Code for Information Interchange. We call this as American Standard Code for Information Interchange. With the help of that, we can be representing characters. The characters are going to be in this range. 0 to 31, they are called as control characters. We have in these control characters. Then from 32 to 127 is called as ASCII standard set. Okay. Then 128 to 255, this is called as here extended set. Like this we have. So first one is what? 0 to 31. They are called as control characters and they are non-printable characters. We cannot print. Enter key belongs to that, backspace belongs to that, alert symbol belongs to that. So they can be called as control characters. Instead of using enter key, you can use control M. When you use control and M, automatically it's going to work like enter key for you. Similarly, control H you can use. With the help of control H, you can be, erasing in the backward direction. Similarly, we have like that other characters. They can be called as control characters. 0 to 31 are called as non-printable characters or control characters. They can be controlling operations. In the Linux and Unix, control D we use to mark end of the file. When you want to mark end of the file, we use control D. With that, what happens? You mark the file ending. Okay. In the Windows or in the DOS, we use control Z to mark end of the file. When you want to mark end of the file, you can use control Z. So they can be called as control characters. Even enter key is nothing but slash and we say sometimes, or control M we say. Similarly, tab character is available. Control H, control I can be called as a tab character. With the help of the control I, you can be making there a tab space. I put here control I, you can get a tab space there. You see here, I am typing control I here, it's jumping by few spaces. So this is called as a control character. Like this 0 to 31 can be called as control characters, but they are part of ASCII. Now from 32 to 127, they can be called as standard ASCII character set. So in that, 32 is going to be space. So from then onwards, you have different types of symbols. Uppercase alphabet, lowercase alphabet, you have digits, then punctuation symbols, then operators, different types of operators you have in that. So 32 to 127 is called as a standard ASCII character set. In this, we have digits. We print digits 0 to 9. 0 to 9 for them, the range is going to be ASCII 48 to 57. This is the range for ASCII numbers 48 to 57. When you take ASCII 48, it's going to be 0 symbol. When you take ASCII 57, it is going to be 9 for us. Let us try to see here what happens. I try to show you that. Here I want to write char. I am trying to write here char. Then it is here ch equal to I want to put 0 here. Like this I am assigning a 0 here. I want to print this. I would like to print here this character. Okay, its value I want to print. 0 value I would like to print here. So therefore system dot, I put like this out dot println. I can use here followed by char. I can write here character dot.
Why can't you put just CH over there?
See, get numeric value. You can take a numeric value, you can be getting it. Try to put here, get numeric value for this. Delete this here, dot, get numeric value for this. We can take here numeric value. We are going to take like this, followed by we specify here character. What is your character exactly? CH. I specify like this. So what gets printed? Let us see in this. Okay. So not numeric value, therefore I think it has got other method. Dot get. You don't have any. It's printing integer like integer. It's converting here. Okay. Dot we use here. Further, So here what I do, just try to typecast it, ch dot, you can't get anything in this, so just put here integer typecasting. With this we can print here int, then followed by ch. This can give you value as 48 for us. We can get this time a value 48 in this. In the bottom you can see the value of ch is 48. So whenever we take 48 value, it is going to be 0 for us. In the same way, we put here some A, capital A, what it prints 65 should be getting printed for us. Try to execute this, it prints for us 65. So therefore, here the range for the, here this is what 0 to 9 ASCII 48 to 57. Then similarly here, a small a to z uppercase ASCII value 65 to 90 we have in this. Similarly, lower a to lower z, the ASCII value is going to be here 97 to 122. So like this is the range we have. Apart from these uppercase alphabets, lowercase alphabets, then digits, we have other characters also, we can be getting them. If you come to this, then try to here see some plus symbol. What do we get for plus? Let us try to see the value for it. It is showing 43 for us, showing us 43. This way it's printing for us. Or we can write small loop. With the help of loop also it can be printed. We can use a small loop with the help of loop. We can print it. It's giving 43. Plus is nothing but here 43. Like this they are getting printed for us. It's getting printed for us this way. So here character is basically ASCII character set we use here, but character is going to be normally Unicode in the Java. Unicode means it requires here 2 bytes of space. It supports both ASCII, and apart from ASCII, it can be supporting other international characters. The other international characters may be, sometimes you want to print rupee symbol. How do you print rupee symbol? Similarly, sometimes you have to print, say, a dollar. How to print dollar? Let us try to print rupee symbol also in this. Here itself, we try to take rupee symbol. Okay, so here it is rupee symbol. Try to find out Unicode character for rupee, INR I say, Indian rupee it is. Let us take it, try to find out that. So Indian rupee sign is something like this, it's saying here. So this one is Indian rupee sign. We try to take the decimal, not decimal data, binary data. Let us try to take this one. UTF decimal 8377. This is here. We take 8377 and try to convert this into character. So here I write int n equal to, assign this data 8377. After that I want to print it as character. Here write system dot out dot println. We take here, we convert it to character, this particular thing here, char, followed by here, we write n. So what gets printed? See in this. It should be printing now for us a ASCII character. A rupee symbol should be coming up for us. It is showing here actually question mark for us. It's not printing question mark. Reason is what? Is it not supporting properly? This may not be correct character. Okay. Rupee. It's not showing properly in this. Okay, it is not showing here. But same program, let us try to do from the command prompt. So the file name is what exactly? This is first class. We go to command prompt. Then we come back here. So here it is. CD Java new apps /p. Here in this write cd first project. We go to bin here, binary folder, type here. In this, let us try to call this. We write Java, followed by here, first class. Here also it's putting question mark only. That means the symbol is wrong. The value, whatever we have, is in fact wrong. Okay, so probably 8377. What I have taken in this? Is it 8377? When you take 8377, it should be coming properly, but not showing here. 8377. It says like this, but it's not supporting in this. We should have that symbol. It's not printing a question mark only we get in this. We need to check that. Okay, whenever we come into this, Indian IT department is saying like this Unicode version. This is HTML code is this. All word process it takes it. Even from here it should be printed. Okay, so Wikipedia, in this what it says, what value it's assigning for us. U plus this is correct only, everywhere it is same symbol, same value we have in that, should be coming properly. So when we take here, we convert into character, n should be getting printed for us. 8377 we have taken, it should not be printing like question mark. Okay, we see later on this why it is so, but this is what exactly it should be printed like a character. 4443 question mark, it's coming here for us. When we are converting the character, try to print like this here. System.out.println, and when we take, it's unable to convert to character, or else we try to take this way, char n equal to typecast it char like this. So as good as same thing, there is no difference between them, should be same like that only. Try to run here. Even here also it's not printing. Okay. We see why it's not printing. Question mark means it's unable to understand that. It means it's unable to understand. I look into that why it's not coming. So here what this Java character is 2 bytes. Apart from English alphabets, English or English-like languages, we have many other types of characters. We have Arabic characters, which is written from right to left. You have similarly ideographic characters, Chinese, Japanese, and Korean. You write them top to bottom. All these characters are supported with the help of the Unicode character char in the Java. So Java char type is Unicode type here. With the help of that, we can represent any character in the world. Okay, with the GUI it works fine because a font is required for that. With graphical user interfaces, that can be working fine in fact. So char is basically character type of data which requires 2 bytes. So it can be representing all the characters of all the languages right now we are using in that. Similarly, we have a Boolean type of data. With Boolean, you can be representing here a true value or a false value. We can have a true value or a false value with the help of the Boolean. So these are going to be called as primitive types. These can be called as primitive types. So these are already defined for us. And apart from this, we can define our own scalar type, one more type, that is called as enum. Enumerations you can make, that is called as enum. You can define your own type of data using enum keyword, that can be enumerated type. Such types you can make, and they can be called as again scalar types. That is called as scalar type of data. This is what primitive type. Even primitive is nothing but scalar type only. We can define our own scalar type with the help of the enum keyword. Enum is required whenever you have more than one constant which come under one particular group. So in such cases, you can declare an enum. Those constants, whatever you want to use, you can use. something like colors. In the case of colors, you may have 256 colors. Starting from 0 to 255, you can have colors. Similarly, the months of a year, you can take from January to December, 0 to 11. In the same way, weekdays you can take 0 to 6, Sunday to Saturday you can take. So that way we can be having here enums. Enums can be useful in such a manner. So this is what about the primitive types. Any questions, please?
Hello, excuse me. Hello? Hello?